Hi guys, welcome to this week's screencast. So we're going to continue with the cardiovascular system. So what we've looked at so far, we've looked at the structure and function of the heart. So we've split the heart up into right and left hand side with the right atrium and ventricle, and then the left atrium and the left ventricle split up by the septum in the middle. Now we've also looked at the conduction system and the cardiac cycle and how they interact and work together to create a heartbeat. So from this, what we need to work on or go on to is the relationship of heart rate, stroke volume and cardiac output. Now, those of you that have done GCSE PE or BTEC sport, you'd know that there is a direct relationship between our heart rate, our stroke volume and cardiac output. So what we need to do is we need to know these. We need to know the changes during physical activity, during submaximal activity and maximal activity, which you're going to go through in today's screencast. And then finally, we're going to work on how is it regulated, i.e. how does our heart rate actually increase and what our body actually does. But first of all, we're going to go week by week. So this first week, we're going to concentrate on heart rate and the changes to heart rate during physical activity and how heart rate is regulated. So that's going to be the outcome of tomorrow's lesson. So if I had a graph, how would I describe the changes of how our body adapts to an increase of exercise? So first of all, we're just going to talk about heart rate, stroke volume and cardiac output. So heart rate times stroke volume equals cardiac output. Now this is going to be one of your Cornell notes, okay? So the title is going to be the relationship between heart rate, stroke volume and cardiac output. And you're going to have these three terms here, and then under cardiac output you'll have this equation. So first of all, heart rate, the number of times the heart or the ventricles beat in 1 minute or in a minute, okay? So that is our heart rate, number of times the heart beats. Stroke volume is the amount of blood ejected from the heart per beat. Okay, say stroke volume per beat, every stroke, i.e. every heartbeat, the amount of blood that is ejected from the heart or the left ventricle per beat. Cardiac output, the amount of blood ejected from the heart per minute. So cardiac output, so the output is a total of 1 minute. How much blood actually is ejected from the heart per minute? Now to try and remember the difference, stroke volume, it's plural, okay, stroke 1. It's not strokes, it's just stroke 1. So 1 beat, how much blood is ejected. As you can see, cardiac output is worked out via heart rate times stroke volume. Therefore, if one of those two, heart rate or stroke volume, increases, cardiac output is going to increase as well. So that's the relationship between heart rate, stroke volume and cardiac output. Heart rate times stroke volume equals cardiac output. So on to what actually happens during exercise, what happens to our heart rate, what happens to our stroke volume and our cardiac output. So first of all, this is going to be a new kind of Cornell note. You're going to have 6 points in total, and when you describe the changes that take place to heart rate during exercise, you're going to have 6 points. You're going to have 5 for submaximal and 6 for maximal, okay, but what I want you to do for your Cornell notes, you just write the 6 down. So you should have 6 kind of lines or 6 tables you're going to be discussing. So first of all, you don't need to write this down. What is submaximal training or submaximal exercise? This is exercise at low to moderate intensity within a performer's aerobic capacity. So you think of submaximal, just think of jogging. Sub always means in kind of PE, anatomy, even science, sub tends to be below, i.e. like a submarine is below the water, below the ocean. Submaximal is below maximal exercise. So we're looking at jogging is what we look at for submaximal exercise. Okay, so the 6 points we're going to go through. We're going to start with the first one. So the first one is our resting heart rate. So before exercise, we need to know our resting values, our resting heart rate. This is 72 beats per minute on average. It's at 60 on this graph. We tend to know resting values as around about between 60 and 80. But A-level want you to know that it's 72 beats per minute. So that is point 1, our resting value before we actually start exercising. And that would be 72 beats per minute. Now, as you can see on this graph, you have before exercise commences here, then we have exercise, then we have recovery. Now, before exercise commences, you can even see that our heart rate increases. So when you're standing at the line of a 100-meter sprint, if you've ever had it before during PE lessons, if you hate PE, if you don't like something, especially exercise, you'll notice all of a sudden our heart rate increases slightly. Now this is known as an anticipatory rise, okay, so point 2 would be anticipatory rise. Now this happens because adrenaline is released. So the hormone adrenaline is released. This stimulates the SA node. Now we know because of doing conduction system and cardiac cycle, the SA node initiates an electrical impulse that creates the heartbeat. The anticipatory rise is a release of adrenaline which stimulates the SA node. So all of a sudden you get an increase in heart rate even before exercise. So hopefully now you can kind of understand sports day if you didn't like it and you're at the start of a 100-meter race. You can now understand why your heart rate increased even before exercise. So that's the anticipatory rise, that's point 2. So then point 3 is this steep rise here. Now the steep rise we're going to come back to during lesson. So if you can just put a star next to the steep rise for me, that'd be perfect, that'd be absolutely fine. Point 4 is this flat line here. So this plateau, it's known as. So plateau, flateau. You need to know it as plateau. So our heart rate plateaus. Now it plateaus because demand for oxygen is met. So the heart rate levels at about 120 to 150 beats per minute because the demand for oxygen is met. So we start exercise. So before exercise, resting value is 72 beats per minute. Before we start to exercise, we get a slight anticipatory rise because adrenaline is released and stimulates SA node. Then when we start exercising, we get a steep rise to try and meet our oxygen demands. Once the oxygen demands are met during submaximal work, submaximal exercise, so jogging, once that is met, once our heart rate has increased, it increases to a certain point and then plateaus because our demand for oxygen has been met. Now, point 5, if you leave that for now, because point 5 is going to be with regards to maximal exercise. So we're going to go on to technically what would be point 6, and that's submaximal exercise because only 5 points is submaximal exercise. That is a steep decline. Now, the reason we get, straight after exercise, we get a steep decline is because the oxygen debt is repaid. So for steep decline, I want you to put oxygen debt is repaid. And that is how we describe the changes that take place to heart rate during exercise. During submaximal exercise, this is what happens. So we should have 1 point resting values, point number 2, anticipatory rise, point number 3, steep rise, which we're going to talk about, point number 4, plateau during submaximal exercise, and this is because the need for oxygen has been met, or demand for oxygen has been met. Then point 5, which is point 6 on your notes, a steep decline, and that is because oxygen debt has been repaid. Now, during maximal intensity exercise, we need to talk about the difference with regards to maximal and submaximal. So first of all, what is maximal? It's high intensity work above performer's aerobic capacity. It will take a performer to exhaustion. So for example, sprinting. So now we're going to look at what happens to our heart rate if we are doing flat out high intensity work that will take us to exhaustion. All points the same apart from point 4 of the submaximal. So first of all, we have our resting heart rate, 72 beats per minute. Then we have an anticipatory rise due to adrenaline being released and stimulating the SA node. Then we have our steep rise, which we're going to talk about. After steep rise, as opposed to submaximal where you get a plateau, you do not get that plateau because it's maximal exercise intensity. So there's a growing demand for oxygen and removal of waste product, which heart rate must continually strive to meet, which it can't meet during full intensity exercise. So we're just going to call that as a gradual rise. Okay, so you also get, well, you get a gradual rise when it comes to maximal exercise. I want that to be 0.5, okay, on your Cornell notes, but this only relates to maximal work. And then finally, we have the steep decline again, which is due to the fact that oxygen debt has been repaid. So on your notes, you should have 1, resting value, 72 beats per minute. 2, anticipatory rise. This is due to adrenaline being released and stimulating the SA node. 3, steep rise, which we're going to talk about. 4, is going to be a plateau during submaximal work. Number 5, can you put as gradual rise and put next to that maximal exercise. And then point 6 is going to be a steep decline, and that is because oxygen debt has been repaid. So hopefully now you should have pretty much 2 core notes. You have heart rate, stroke volume, cardiac output, and then on a separate piece of paper underneath that we should have described the changes that take place to heart rate during exercise, and you should have 6 points which we've just gone through. So if you can do your questions, please ensure you create questions to help you remember these, and I'll see you next lesson where we go through this more. Thank you. Bye.